This is for all the kids that rock up early. They get the special Easter eggs. So, it's a cannonball. Air resistance, no air resistance. Let's look at the force vectors. Fire. No, go. Bang. I don't know what that was, but anyway. Bang. If we include air resistance, and let's just add the diameter to make it prominent, we get that. Boy. So, look, the time, I'd like to shoot them at the same time, but slow this sucker down. Look at that muzzle flare. Amazing. Okay. Acceleration or components. Yes. Do it. Oh, no. Look, there's a backwards component. There's a backwards component that gets smaller over time. Wait, why did it get bigger? Why did it get bigger? That shouldn't have happened. The backwards component should get small and just stay small. For some reason it's getting bigger, which is saying that the horizontal component's getting bigger, but it really should be. So there you go. Without air resistance, boom. Amazing. I will place this link for you all to enjoy. Dude, I was going to say. Jeez. Dude. Chuck that there. Alright, so that's something for you all to play with. We are screen capturing, so yeah, I'd love for that to show both scenarios at the same time. You'd notice that it reaches its turning point faster. Because, anyway, let's get to our booklets. Now, gentlemen, I'm not going to be here tomorrow. So as I may have said, I'm screen recording this lesson. The other class who don't have their lesson today will watch this lesson on Wednesday. I'm going to leave you guys some work to do tomorrow. It'll be, projectile motion questions. I might highlight some Giancoli questions again. You'll be using Wednesday's lesson for working through the problems. Okay, so that's your work lesson for the week. Now, there's actually a lot. I've got to flip the screen here. I didn't leave enough room for my max height equation. I should have given a whole damn page. So we might run off the side of the page here. So maybe write really small. We've only really got a third of a page. So I'm just going to zoom in for a max height equation. I also printed out some notes and it printed it in A3, but anyway. Let's get cracker-lackin'. Let's just quickly sketch position time. And let's give an initial and then one of them bad boys. And then at the top here is the turning point. The turning point is when Vy equals 0. So at the top, it has 0 vertical component. I'm going to also add an initial, S initial. Okay? Recall the turning point is the time we get negative B on 2A. And in maths talk, that's negative U sine theta all over gravity. Okay? Now, what I would then do is let's make the other equation. Oh, let's just stick with black here. Let's find S maximum. Let's find the maximum height. That's going to be the time of the turning point. So we're going to chuck the turning point time into our ut plus half a t squared. Let's throw everything in. We're going to go u sine theta times negative u sine theta over g plus a half of g outside of negative u sine theta over g. All right? And now let's do some stuff. We get negative u squared sine squared theta over g. Did I miss a... Oh, and I forgot to square that term out the top. Sorry, that should be t squared. My bad. That one there. Make sure you square it. I'm in a good mood, can you tell?
Yeah.
Let's see if we can break him.
Right.
Get Mr. Murray in a bad mood. See, let's see. I'm too bipolar. All right, so this would then be plus a half of g outside of negative u squared sine squared theta over g squared. Red pen, cancely, and we get... Oh, I forgot my plus S initial. Plus S initial, man. Oh no. Maybe it'd be better if Mr. Murray was angry. Forgot my S initial. Look what we get. We get minus a half plus a half. Oh, sorry, minus one of them plus half of them. Well, that's minus a half of u squared sine squared theta over g plus S initial. We could then rewrite this as minus u squared sine squared theta over 2g plus S initial. We could keep simplifying it. It's going to be that whole term at the top is just u squared. So I could sort of simplify it as negative u squared over 2g plus S initial. This whole term here is going to, on our diagram, is basically this bit. And then S initial gives us the rest. All right? So that first term, can't get out of my seat. That first term here basically tells you the height above where it was thrown from. And then you consider, well, is it already 4 meters above the ground? Okay, so that's our equation for the maximum height. All we did is we set the the vertical component to 0. Okay? There's actually another way to get to it. Let's have a look-see. We have another equation, if you don't mind me zooming in over here. V squared equals u squared plus 2as. Would you agree? Plus, let's rearrange this for s, okay? S equals v squared, take u squared, all divided by 2a. But then I'm going to go plus S initial, because I always like to consider where we're starting from. All right? Now, S max is when Vy equals 0. So our S max equation, look what happens. Negative uy squared over 2g plus S initial. Bruh. Oh no. Brother. Brethren. Alright? So you get exactly the same thing. You don't need to expand it. You could, at the start of the question, you could find what uy is. You don't need to write u sine theta all squared becomes u squared sine squared theta. You could just say my vertical component is 4, and so 4 square is 16. 16 divided by 19.6 gives so many meters positive. You'll notice as well, gravity contains the negative, and you get a double negative. So you've got to be careful here. If you had something that's shot downwards, well, you're never going to find a maximum. So you've just got to be careful. This will really only work if you have something that's fired upwards, because we're then considering the vertical component initially. So I had an example, and do we all still have space on our page? Because I've just gone into like micro mode. Not much. I had an example of, let's suppose S initial was plus 4. And let's suppose that we threw something up with an initial vertical component uy equals plus 5. So I haven't given an angle, I haven't given the speed, let's just figure out the vertical component. So we're not going to worry about any horizontal stuff for this question, okay? So let's use that information down in this equation which we've derived, okay? So we'd say uy equals plus 4, no it's not, it's plus 5. S initial is plus 4, gravity is negative 9.8, and we can set Vy equal to 0. Okay? So away we go. S maximum, negative 5 squared over 2 lots of negative 9.8. That's the height above where it's thrown from. Let's also consider that we are 4 meters above the ground. So we get a value of 1.28 plus 4.00, probably to 36. Huh? I just did undo, and it undid something that was like 7 keystrokes back. Oh, that's weird. Okay. There you go. Now, I had written down in my previous lesson last year, if you didn't know this equation, if you didn't derive it and you weren't able to use it, the long way, again, you don't have to write this if you've, well, I've got so much space here.
No, bro.
Can I lasso this and like make it big?
Yeah, you can.
Uh-oh.
Oh, that's good. So you're going to take the yellow wire.
No. Oh. Good enough. The long way of doing it is step 1, find t. So I'm just going to do this very roughly, and you go t equals v take u over a equals 0 take uy over ay equals negative 5 over negative 9.8. You find the time taken, and it turns out that it takes 0.51 seconds to get to its turning point. And then you could, step 2, throw that into s of t equals ut plus half a t squared plus s initial, and you throw everything in. 5 by 0.51 minus 4.9 by 0.51 squared plus 4. All of that would give us 1.28, and then we add the 4, which becomes 5.28. So it's one extra step, which you don't need to do because we substituted that into this equation to get that nice equation that's in the box. Again, another reason why I encourage students to include S initial, consider where this is, because a lot of students would forget the 4. And so they would answer the maximum height is 1.28. No, that's only the height above where it was launched from. You also need to consider that it was launched 4 meters above the ground, so consider it and include it. Okay? Okay. Now, there's two, hang on. No, shush. There's 2 questions. I'm going to leave them for you to do in the second half of the lesson. Let's get all of the writing notes down and the nasty stuff down first. Okay? Again, I must premise, this question has appeared in St. Mark's and St. Mary's tests. I don't think that it would appear in WACE because there's so many steps involved. But there is another way that we can substitute one equation into another. So could we consider, let me just bring up my little cheat sheet with my workings. All right, here we go. Consider this bloke here who is now going to be drawn slightly larger because we've zoomed out. Okay? And he kicks a ball starting off 1 meter off the ground. It then travels in a projectile path, like so, and is caught in a hangar some distance above. Bless you.
A cross-country player.
Sure, why not? Now, I am going to give you some initial conditions, and depending on those initial conditions, we can solve the unknown. Let's suppose that it is kicked 40 degrees to the horizontal. Let's suppose that the hanger is caught 60 meters away. All right? Now, there will only be one speed where this scenario occurs. There will only be one speed where vertically it's 2 meters above and horizontally it's 60 meters across when fired at an angle of 40. Have a look at the screen for me now. If he kicks it too slow, it'll do this. If he kicks it too fast, it'll do that. But at just the right speed, it will exist at that coordinate at that time. Okay? So there will only be one solution to solve for u. Now the problem is, we need to get an equation for time. Well, down here we know that Sx, sorry, let me keep that in blue. We need Sx equals uxt, which is u cos theta t. And so I could write an equation, therefore t equals Sx on u cos theta. Now our equation here, it would be 60 on u cos 40. Okay? And so I'll highlight that's our equation 1, which we will sub into equation 2. Okay? Then we have our other equation from the vertical, and that is that Sy equals uyt plus a half ayt squared plus S initial. Well, we're going to say 3 meters equals u sine theta t minus 4.9 t squared plus 1. Yeah? That's our equation for the vertical. At some point it's 3 meters above the ground, and it started off 1 meter. The other way to do this is to go, well, the displacement from, it displaced itself up plus 2. Well, you can see if I take him across, the 1's going to disappear anyway, so it doesn't really matter. Okay, now that's our equation 2. We're going to sub 1 into 2. And it's going to look nasty, but let's just write it out for what it is. We're going to get 3. I'm going to put the 2 on this side. Cancel him. Okay. 2 equals u sine theta times 60 on u cos theta. Shall I write 40? Shall I write 40? Yeah, let's write 40. Sorry about that. Minus 4.9 bracket 60 on u cos 40 squared. Now, you don't actually need the trig identity. You can literally put that into your calculator. 60 on cos 40 gives something. All right, and sine 40 gives another. You can convert it into a decimal. But we can simplify. There's a trig ID that sine theta on cos theta equals tan theta. Okay? The reason I've probably jumped the gun, let's go, look here, we get 60 u sine 40 over u cos 40 minus 4.9 60 on u cos 40 squared. That equals 2. So you can see why this is probably not going to appear in an exam, because we're already like 5 steps in and we still have about 5 to go. In that first term, that just becomes 60 tan 40. But the boys that aren't happy or familiar or strong with trig, you could just literally write in your calculator sine 40 over cos 40 and it would spit out a number which is actually also going to be tan 40. Okay? 2 equal minus 4.9 by blah on u cos 40 squared. Now, our only unknown, conveniently to use cancel, that's just a number, but unfortunately our unknown is locked away in several sort of mathematical steps. So now you just have to grind your way through picking apart your equation. Now, 60 tan 40, I'm going to subtract 60 tan 40 from both sides, and abracadabra, you get 48.3 equals negative 4.9 60 on u cos 40 all squared. Then I'm going to divide both sides by negative 4.9, abracadabra, 9.87 equals bracket 60 on u cos 40 all squared. I'm then going to take the square root of both sides. 3.14 equals 60 on u cos 40. Then I'm going to flip both sides. U cos 40 times both sides by 60 on 3.14. Divide both sides by cos 40. You know, I'm starting to skip steps, but we get u equals. Finally, we can figure out what it is. Now, before we do so, if you kick a football and it is marked 60 metres away, do you think it's going to be a fairly fast speed? Yeah? I mean, that's like, that's, I can't kick that far. It's going to be a big number, right? It's not going to be 4 or 6. That's something that you throw into the trash can. That's not fast enough to travel 60 metres. So, again, your calculator spits out 24.9 metres per second. And then, obviously, if we're asked for velocity, it's then at 40 degrees above horizontal. Again, highly unlikely that this question would appear because of all the math steps. That's like 10 steps, 10 marks, and feel sorry for the kid that stuffs up step 2. Yes?
How do you know it's 40 degrees above the horizontal?
Because we were given that at the start. Yep, we were given the theta.
Oh, yeah.
Yep. Now, the next cool thing is, and Brownie's just made me think about something. If it was fired that way, then something would happen. You know, this would be a negative, and you would end up not being solvable. So, again, if you try and set the parameters that can't physically exist, you'll end up doing something naughty like taking the square, you know, probably here, you'd end up taking the square of a negative number. So the maths will not let you put in parameters that aren't physically possible. So that's another, you know, if you get error syntax or something, it might be because it can't physically exist. Yes?
Do we solve for t in this situation or not?
Well, we didn't care. But now that we've found u, there could be a part B to this question. Part A, find the speed. Part B, find time. Well, look, you've got 2 equations for t. You've got a nice easy one, and then you've got a nasty one. So yeah, we could say how long would it take. Now have a think. If you kick a torpy 60 metres out and it's caught at the goal line in a hanger, how long do you think the ball's in the air for? 3.1, about 3 seconds. Have a think when you watch footy and they kick a goal from 50 out. 1, 2, maybe 4 seconds. Let's figure out for funsies. I don't think I solved for t. Yes, I did. T equals. Oh wait, you solved it, you bugger. It's 60 on u cos 40. Okay, 3.15 seconds. Good guess, well done. Again, sounds plausible. Now, yeah, I'm going to stop here. I wanted to get to the... Yeah, let's keep going. Skip that. I'll get you to do that question. Just bear in mind, guys, these are tricky. Please do not... How do you spell tricky? these are tricky. Please don't think that all the questions are going to be like that. This was tricky. When I give you guys time to work questions, you're going to find them a lot easier. So I do not want to be scaring you thinking, oh my God, I'm dropping out of physics because none of this makes sense. I apologize. Let's just get the stuff out of the way that's not in the syllabus. All right. Now, let's go another scenario. Let's suppose, I'm going to use an example here. A golfer, 90 degrees above the green. 90 meters. Let's take a golfer, 90 meters above the green. Don't worry. Hits the ball at a speed of 65. But here's the thing. We don't know the angle. We could get a low angle or a high angle. There are going to be two angles that might be able to get this hole in one. Okay? He could lob it up nice and high, in which case it spends more time in the air. So with a reduced horizontal component, it still manages to travel that distance. Or you could hit it at a low angle. It spends less time in the air, but it has a greater horizontal component. So it still is able to travel the same horizontal distance. We need to know that Sx is, I've got here 300 meters from the hole. Okay?
What does it say next to theta?
65. So now you'll notice a slightly different question. We've been given the speed, but not the angle. And with this scenario, you'll get two possible thetas. Okay? So I'll just sketch again the low theta and the high theta. Okay? Now, from the vertical, S equals ut plus a half a t squared plus s initial. Oh wait, yeah, no, it is 90, yep. I'm going to write plus 90, 0 equals 65 sine theta minus 4.9. Wait a second, I've missed a t. Hold on. Minus 4.9. Okay. And that is going to be my equation number 1. Then from, that's from vertical, right? So, from y we get that equation. From horiz we get the other range equation, and that's just Sx equals uxt, which is u cos theta times time. And so I'm going to write 300 equals 65 cos t. Cos theta t. Therefore, t equals 300 over 65 cos theta. There is our equation number 2. Again, we're going to sub number 2 into number 1. And so we get 0 equals 65 sine theta times 300 over 65 cos theta minus 4.9 300 over 65 cos theta all squared. Oh, that's different. Plus 90. Now here, make sure I've got everything right. Yes, that's right. That's right. Okay. Okay. Am I missing a sine theta? No. What do we get here? We get 365 sine theta on 65 cos theta. Plus 90. We might be able to cancel out our 300s, I think. Are we happy with cancelling that out?
Yep.
So we get 300 tan theta. So we needed that first trig identity. Okay. minus, I'm running out of room here, 4.9, 300 times 1 on 65 cos, oh wait, hang on, I'm stuffing up my maths. 300 on 65 cos theta squared plus 90. Now, another trig identity. And that is that 1 on cos, let me write that flat. 1 on cos squared theta equals tan squared theta. So we need to get our cos squared term into a tan squared term, and then we get a tan theta term, a tan squared theta term, and a no term. It's going to be a quadratic. Yes?
So I'm not solving this because science.
Oh, plus 1. Sorry, plus 1. My bad. Plus 1. Thank you. All right. So we're going to get these all equal 0. 0 equals 300 tan theta. Now, minus 4.9. I need to sort of do all of the squaring stuff. So, could somebody do 300 squared over 65 squared for me?
21.
Is it? 300 squared over 65 squared.
21.3.
Is it really? Okay.
Good job.
Sorry.
Okay. And then could you times that 21.3 by minus 4.9, and I believe we get like a 104. Thank you. Cool. 300 tan theta minus 104.36 outside of 1 on cos squared theta plus 90. All right. So now, what would we have? That's tan squared theta minus 1. Hang on. Wait. Where's plus 1? So we've got to add a plus 1. So we get 0 equals 104.36 tan squared theta plus 300 tan theta plus 1. Where's the, tan squared theta plus 1 plus 90. Okay? Are we happy there? Now, I almost forgot the plus 1. Phew, glad I didn't. We've got to expand this out. Again, you see why this is not in the syllabus. Oy. You get minus 104.36 tan squared theta. I'm going to subtract the minus 104.36 from that, and we get minus 14.36 plus 300 tan theta. So I've just the numerical terms. So now, quadratic. A, x squared plus b, x plus c.
So why 5 DP?
I don't know, just that's the decimals that I got. It shouldn't really matter. Now, using the quadratic, I've run out of room, but you will get tan theta equals plus or minus. Oh no, it'll be 2.826 or 0.0489. Theta equals 70.5 or 2.80. Now, the reason I wanted to show you this working out now is because tomorrow I'm going to give you some work. And, oh, hello. No thanks.
That disproves that the...
Hang on. In the Giancoli Physics 2D motion, there is an absolute banger of a question. Why are there two different angles? Sketch the two different trajectories. I reckon you could solve for those angles using that crazy example that I just gave. Bear in mind, it will not appear in a test or an exam because too much maths. Okay? There might also be more questions about calculate the two angles. But I'll have to have a sit down and see if we can find them. Okay? All right. So, oh, goodbye. So, I apologise for jumping right to the end of the topic. How about now I give you some time to work on the easy, medium, and hard. So, I will stop the screen record, or maybe I'll leave it going for the rest of the lesson. Do this. Get going, gents. Oh, and yeah, that, yep. So, and I'll just set up a few things for you to help out here. Okay. Now it's up to you to decide whether you're just going to jump straight into quadratic to solve this, or you can split it into steps. Find the time for it to strike the ground, find the velocity that it strikes the ground, but you've got to do both. And the maximum height and the range. Oh my gosh. Okay? So you've got to find everything. That's why you've got a whole page to work on.
Should we make the x-axis time always?
For this, yes. Because for the quadratic, you're solving t equals. Yeah. Yep. And so again, always sketch your trajectory. You'll get a negative t, you'll get a positive t. We're obviously looking for the positive time. And that you can use that positive time to solve for the range. Okay. So there's just a few things to help you. It's now on the OneNote if you want to bring it up, because I'm now just going to quickly sketch the next one. I'll try again. Something like that. It's not the best diagram. Oh dear. This is one example that we haven't encountered yet. If it's thrown downwards, then you're going to get 2 times, and then the positive time is going to be lesser in magnitude than the negative. All right? So again, have this in your mind, what you're expecting, and that way when you finally solve it at the end, if you made a mistake, it might manifest itself in your calcs. You go, oh, hang on, wait, I'm not getting the right values, I must have made a mistake. Okay. 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 Hello.
So I've been going through this.
Oh, yes.
So I've subbed in the two equations, and I've got down to here, and I'm getting a negative discriminant.
Okay.
And I can't really see where I went wrong.
So this whole term comes to 100. Now, it shouldn't be 180. I got 104.36. So do you want to just check the 300 squared over 35 squared? Just quickly check that.
So you're looking
This
at,
should become 104.3. And where did this plus 180 come from? That should be 90.
So I'm saying that in overall, my total my total
Okay,
displacement
hold
was
on. Let me, straight away, you're either going to write negative 90 there,
Yep.
plus 0, or you take that across, plus 90, set it to 0. So 0 equals. Once you get it in the 0 equals, you can then use the quadratic. Well, ideally, once we get to the bottom. So now that should be 90. That should be 90. Follow it through. That 180 might affect the discriminant.
Quick question.
Yep.
I put negative 90 here because my total displacement downwards is going to be negative 90.
Then why did you write plus 90 here? So you're
my initial
so you're using both methods. You're using both methods at once. So you pick one or the other. You say I'm going to displace it negative 90 from the start, in which case
Okay.
0 equal negative 90 there, and we don't consider S initial.
Yep.
Or I'm going to consider S initial, and then this becomes 0. So then you're setting up 0 equals plus 90. So either you've got 0 plus 90, or you've got negative 90 and nothing. And when you take it
I see,
over,
yeah.
so
I see
you've
the
done
logic.
both.
Yeah,
Now-
I see the logic now with the plus 90 at the
Okay,
end.
so
because,
just check that, and also check this, because I'm not seeing. I mean, I'm getting a 104.3.
and I'm getting a 360.
So here, just do this fraction for me. Do that whole fraction of minus 4.9. Yep, you've got it. You just do it now. 360. 30 squared over 25 squared. Or was it 65 squared?
Oh, did you put?
Did I make an error? It could be possible.
No. I think you might have put 65 squared at the very beginning. You might have done that. And I just didn't pick it up.
All right. Normally, if I write the wrong thing but say the right thing, it's 65.
Yeah, 65.
Okay.
Yeah, I see what you're doing now.
So go back. This whole term should be 104.3 and then 90, and then have another go.
Got it. Thank
Okay. If you want to work it on the board, there's plenty of, because you've run out of paper, you feel free to do it on the board. Yep. All right. How are we going for time? Have we got 2 or 7 minutes left? 7. All right. I might play catch up here, so if anyone's happy to help me, I am going to figure out what I'm doing. Would somebody mind telling me what UY is?
7.18
Thank you.
meters per second.
So UI would be 17 sin 25, because of course you.
Yeah, which they said is 7.18. Yep. So I've skipped some steps, but the people that are watching this tomorrow, it's going to be difficult for them because do they still have their headphones in? I don't know. Next, would somebody mind telling me what the discriminant is? That being this whole bit here.
Vy.
Yeah, but what is it as a number, you smarty pants? What is it? Cool. And then I want the positive time, so I'm just going to take the negative. Quick, bad at maths. 33.28. Yes? And then, yes? Somebody want to figure out the time for me?
It's 1.4.
No, it's not. 3 point.
I think this root is 3.
Okay. 3. What's the discriminant? Oof. That's okay. We are non-selective Anglican all boys day school. What are we now? Is it 28?
Sorry, 21.1.
So can we just do it similar?
No, there is no simpler method.
Y sine theta.
But that's for the turning point. But that's not what we're solving for here. I'm finding the total time.
Sorry, 28.
28. Okay, and velocity time. Sorry, time in seconds. All right. Now I've just found time of flight, so that's done.
2 times negative 9.2 times.
I might find the range of the object and the velocity on impact.
That's very good.
Could somebody please tell me what the horizontal component of the motion was? That being 17 cos 25. In fact, you want to just go ahead and multiply that by 2.88 and that'll give us the range.
44.37.
Sounds good. Lastly, well, not lastly, because we've got more stuff to do. That was the range. The velocity on impact, that's going to require a quick little sketch of it's going to hit the ground doing something like that. And we know the discriminant was 21.1. Ben Lane was going to tell me the horizontal component initially, which was 17 cos 25.
15.4.
No, yes it is. Yeah, that's right. And then V and theta. So V square root 21.1 squared plus 15.4 squared.
26.1.
And I'll take the angle to the horizontal, which is theta in the diagram. That's arctan 15.4. That will give us an angle slightly greater than 45.
53.9.
So finally, V equals 26.1 Okay, so that's our velocity. And lastly, the maximum height. Well, I'm going to just go S equals Vy squared, take Uy squared over 2A plus S initial. Set that term to 0, and we get negative Uy squared on 2 lots of negative 9.8 plus our 20. And so that's going to be, what was Uy? Someone said it was 7.18. All right. Would somebody mind telling me what the total height off the ground is? Hey? 22.6. Thank you. So basically, this section here is negative Uy squared on 2G, and this section here, no it's not, I'm stupid, try again. This section here is S initial. This section here is negative uy squared over 2g. Yeah? Happy with that? Please remember, it's uy. So even though I wrote uy, please remember that is still u sine theta. So again, just make sure you don't forget that. Don't go putting 17 squared, or else you'll get a huge answer. Okay? Cool. That's time, gentlemen. Are we good? Are we happy? I haven't made any errors. Do this other question for me, please. That's doable. Do the netball question. That's also doable. Please recall, solving for the angles, way crazy. All right, I will give you some assigned work in tomorrow's lesson, and it might be doing the Jankoli questions. God bless. Godspeed, gentlemen.